also show you here that doing a left-handed convex shear is just as simple as doing a right hand. It's just simply the mirror image in the arm set, and you're now working on this side of the wheel, and we'll run the wheel in a reverse position. And I've got my burr all the way. Now polishing out my edge. And that's all there is to doing a left-hand convex. I don't have a a left-hand bevel here. However, the position for it is just a mirror image of the right hand bevel. Simply set your angle and sharpen the left hand. I'm not here to spark any more controversy. It's simply on the machine. I'm just going to demonstrate how you can put a progressive angle on a shear. That means the angle changes from the back of the shear to the front of the shear with a decreasing angle as we move towards the tip. This can be done on a right and a left-handed shear. You simply lock the cam in place. It forces the blade to lower as you come away from the wheel, or if you're a person that uses the tip going in, it causes the shear blade to lift as it goes in. So either way you do it, you still come out with the same angle change. I'll go ahead and run this one. And our angle changed approximately 5 degrees from the back to the front, because it's 2.5 degrees per inch of shear, and that's approximately a 2-inch blade. Okay, this is a brand new shear straight out of the package. Never been touched. I'm hoping the little silver line shows, and it's also a true convex shear. We moved to this shear. It was sharpened on the Ez-Vex. You can see, well, if it shows, there should be just a very small silver line in a true convex. When we moved to this shear, it was done on a vertical hone. You can see we now have a hollow grind down that edge, creating a new configuration for the shear. When we come to the shear here, it was convexed on a flat hone, creating the silver finish rather than the coating. It has wiped the coating off the shear.